Alright, so we are graphing linear equations. So this is just like graphing the line y equals 3x minus 1. That's your starting point. So you're still, this is normally y equals mx plus b. You begin at the b, move with the m. So I'm beginning at my y-intercept, which is -1, so I get to put a big old dot right here. And then my slope is 3 over 1, so I'm going to rise 1, 2, 3, and I'm going to go over 1. You can go down 1, 2, 3, and over 1. Either way, put a semi-decent line through this. Please feel free to use a ruler. Use a ruler. And this is a solid line because this guy right here is greater than or equal to. So the reason that it is a solid line has nothing to do with the greater than and has everything to do with the equal to. Okay, because it's equal to it, all the points along this line are possible answers. So it has to be solid. And then the last piece here is that your y values need to be greater than this. So I want you to just focus on your y-axis. Don't look at any other part of your graph and say, where are my y values going to be greater? They're going to be greater above the line, so you're just going to shade above the line. All right? Second option. This guy is not solved for y, so we need to do that. You need to leave the inequality, that's this piece, in here when you do that, because if you, remember, if you're dividing by a negative, it's going to flip over. That will absolutely affect your answer. Very, very important. We're not going to be dividing by a negative in this case, but you will see some with it. So, divide each piece by 2. I think it's helpful to put the 1 here. This guy will knock out, that guy knocked out. So we got y is greater than -1/2 x plus 4, just greater than, not equal to. So this is going to be a dashed or a dotted line. Okay? Just kind of keep that in mind. So we've got plus 4, it's my y-intercept. My slope is -1/2. I know that my graph needs to go down. So if I go down 1, I think I'm going to have to move over 2 to make sure it has that negative slope. If I went up 1, I would have to go to the left 2 to force it into that negative slope. One way to make a dashed line very easily is to just kind of keep going with the slope and making a bunch of points. Keep in mind that, you know, the dotted line does cross here, not just right at nice points, it can cross at decimal places, but this is an easy way to make it a dotted line. Again, just make sure that you are careful and that you're using a ruler, because it will affect your answers. Alright, and then this guy, y is greater than, so greater than my y-axis. My higher numbers are above, so I'm going to graph above. Alright? We'll practice those some more. Maximizing constraints. You're going to need this. We're going to put all these things together. You might know where we're going with this from Algebra 2. If not, it's totally okay. And if this is kind of strange and obscure and you're not sure why we're doing this, it's fine. We're just going to roll with it, and then you'll see when we put all the pieces together, it'll be a lot easier if you already know this piece. So just for good practice, let's write the inequalities that are created here. So this is actually a line that would continue. This one's actually a line that would continue. This is actually a line that would continue. Okay, but the only place where all the shading overlaps is in this triangle. So, the slanted line here, my y-intercept is at 0, and my slope is 2 over 1. So I've got 2x plus 0. You're welcome to write in a plus 0. You don't have to. And my y values here, it's shaded below, so it is less than, and it is a solid line, so it is equal to. This lovely horizontal line chops off the bottom half here. So all the y values are going to be above -1. So y needs to be greater than or equal to -1. And similarly, this vertical line eliminates this section of our graph here. So all of our x values are going to need to be less than or equal to +1. So those are the equations that created this picture. And we will look at a bunch of them and practice. Okay? Okay, so let's maximize these constraints. If you don't know what that means, it's totally fine. I'm going to tell you. What we're going to do is we're going to look at our intercepts here. So where these different equations, inequalities rather, intercepts, what are the coordinates? Okay, so this first guy right here is at 1, 2, 1, 2. This second guy right here, notice how I like colors, is at 1, -1, 1, -1, and our third one is in between here, and since we know our slope is 2 over 1, we're dividing by 2, so it is at 1/2, or 0.5, whichever you prefer to see, comma, -1. Now what we're going to do is we're going to take this guy right here. They're going to give you some sort of equation, and it's usually C equals, because it normally has to do with money and cost, and don't worry, we'll put it all together to give you some context, but let's just look at the procedure here before we get too in-depth with it. So, all you need to do, I'm going to even sneak over, we don't need the rest of that at all anymore, we just need this. All you need to do here is substitute in your x and your y values to this equation. So, 7 times 1 minus 5 times 2, that gives you -3. Then, this second guy, 7 times 1 minus 5 times -1, should give you 12. And the last one, 7 times 0.5, or 7 divided by 2, minus 5 times -1, and that equals 8.5. So since we are maximizing constraints, the one that maximizes the constraints here is this point. That would be super, super, super important, okay, because it is the highest number. All right? There you go.